So once again welcome back. Today we are going to discuss problems on Fourier series. Before that, let us start with the Bernoulli's rule of integration. Bernoulli's rule of integration that you have already studied in our previous semesters. How we can apply Bernoulli's rule of integration to find the integral of product of two functions. So this is the generalized case of integration by parts. Suppose you have two functions u and v, and you are supposed to find the integral of the product uv. Then first you have to choose first and second function. Here I have treated u as first function and v as second function. So the integral of the product uv will be first function into integral of the second function minus derivative of first function into integral of second function plus second derivative of first function into third integral of second function minus third derivative of first function into fourth integral of second function, and so on. So here in each term you have to change the sign, minus, plus, and so on. Along with that you have to go on differentiating first function and integrating second function. So this will be continued till you get zeroth term. In some step you get 0. Till that you have to continue this process. When you get 0, you have to stop the procedure there. So here in each step you have to change the sign and differentiate first function, integrate the second function. Here are some examples. X square cos x dx. When you have product of two functions, to identify first and second function we use Ilate formula. Ilate, I-L-A-T-E. Inverse function, that will be given more preference. Logarithmic function, algebraic function. Algebraic function means the function of the form x power n. Trigonometric function and exponential function. So exponential function will be the least preference function. So here x square cos x, algebraic and trigonometric function you have. So algebraic function obviously that will be the first function, cos x, trigonometric function will be the second function. So first function we have written as it is into integral of second function, integral of cos x sin x minus derivative of first function, that is 2x, into integral of second function. So integral of second function is sin x. So again you have to integrate this minus cos x plus derivative of first function, second derivative of first function, that will be 2 times third integral of second function minus sin x. Next, if you continue this procedure, derivative of 2 you get 0. So I have to stop here. Second example, integral 1 plus x sin x dx. Here also 1 plus x being an algebraic function. Algebraic function means it will be of the form a polynomial p of x. So either it may be x power n or x power n plus a naught x power n minus 1 plus a1 x power n minus 2, and so on. So this will be first function, second function. So applying Bernoulli's rule, you get first function into integral of second function. So integral of sin x you get minus cos x minus derivative of first function you get 1 into again integral of minus cos x, that is minus sin x. The next step you get 0. So we have to stop here. So integral x cube e power 2x dx. So obviously x cube will be first function and e power 2x will be second function. So first function into integral of e power ax is e power ax divided by derivative of ax, that is a. So integral of e power 2x will be e power 2x by 2. So x cube into e power 2x by 2 minus derivative of x cube, that will be 3x square into e 1 by 2 ಆಗಿರುತ್ತೆ, 1 by 2 into integral of e power 2x. So 1 by 2 into e power 2x by 2, that is e power 2x by 4, plus differentiating 3x square, you get 6x into e power 2x by 4 you have already in the denominator. Integrating e power 2x, you get e power 2x by 2, so that will be e power 2x by 8 minus 6 into e power 2x by 16 similarly. So next, if you continue, you get 0, so I will stop here. And recall these two results. These two results are very much important to find the values of the constants a0, an, bn. In that step, these two will be very much important. So the first integral says, or first point says, if you integrate a function f of x between a and minus a, then the value of that integral will be 0 if the function is odd, and this is 2 times of integral 0 to a f of x dx. Here we have to write 2, that I have not written here. So integral a to minus a f of x dx will be 2 times of integral 0 to a f of x dx if f of x is even. See, it is an equispaced integral a to minus a or minus a to a, whatever the limits, don't worry about this. A to minus a or minus a to a, both are same. So integral a to minus a f of x dx will be 0 if f of x is an odd function, and it will be 2 times of integral 0 to a f of x dx if f of x is an even function. Here if you want, you can also write minus a to 0, no problem, you get the same thing. Only thing is, we have to consider only half of this interval. Either you can take 0 to a or 0 to minus a. This is about Bernoulli's rule of integration and a formula that is most important to solve problems on Fourier series. So convergence of Fourier series. Convergence in the sense, suppose we find the Fourier series expansion of the given function, that as I said earlier in the previous class, if you give some particular values for x in the left hand side, you get some value. If you give the same particular value on the right hand side, which is a series expansion, then you get some value. If both are same, then we say that the given series on the right hand side converges to the given function f of x. If the values are different, then we say that the given series does not converge to f of x, the given function. Now we have special cases here. If the function is continuous, no problem. If the function is continuous at all points and function satisfies Dirichlet's conditions, then no problem. You can give any value of x on both sides, you get the same value. But when the function is not continuous, or when you are going to check the value for which is an end point of the interval, in that cases it will not converge to f of x, it will converge to some other point that are given by this. So if x is a point of discontinuity, that means if the function is not continuous at the given point, then it converges to f of x minus left hand limit plus right hand limit by 2, the average of left and right hand limits. And similarly, if you are taking an end point, if you are substituting x equal to either minus pi or plus pi, in both the case the series converges to f of minus pi plus f of pi divided by 2. So on the right hand side, if you are taking x equal to pi, then left hand side it should not be just f of pi or f of minus pi, it should be f of minus pi plus f of pi divided by 2. Understand this carefully. You have the series expansion f of x equal to something, you need to find the value of the series or the function at x equal to pi. Then on the right hand side you take directly x equal to pi or minus pi, no problem with that. On the left hand side you should not submit directly x equal to pi. Left hand side it should be f of minus pi plus f of pi by 2. Similar cases you have here. If the given interval is 0 comma 2 pi, then if the function is continuous at the point x, then obviously the series converges to f of x. If the function is not continuous at the given point, then it converges to left hand limit plus right hand limit at that point by 2. If you are taking an end point, then it converges to f of 0 plus f of 2 pi by 2. So this is about convergence. So generally you can follow this. If you have any doubt, if the function is clear, that means it has no discontinuities, you can take this one, or you can generally follow this, because even the function is continuous, then this obviously reduces to this only, because when the function is continuous, both left and right hand limits are equal, then you get 2 times of f of x plus by 2, that is f of x plus, that is same as f of x. So generally I suggest you to follow this one. Given any point x, it always better to take the point of convergence to be f of x minus plus f of x plus divided by 2, whether it is an end point or whether it is a point of continuity, whether it is a point of discontinuity, don't worry, just follow this. Even if you have continuous function, then it reduces to this. If you have end point, then reduces to this. No problem with that. Now, how to find Fourier series of a given function f of x? Now, in the problem statement, you will be given with a function and you will be asked to find the Fourier series expansion of that. So generally in the problem statement we can find this: a function f of x on the interval 0 comma 2 pi or minus pi comma pi. Except these two intervals, you are not going to given with any other interval. Function will be given on 0 comma 2 pi or minus pi comma plus pi. So first thing you have to write, the given function is periodic with period 2 pi, and then write down this formula: f of x equal to a naught by 2 plus summation a n cos n x plus summation b n sin n x. So this formula you have to write down. So given the function, observe this carefully. First write down the given function and the interval. So first you have to write down the given data. Second, write down general Fourier series expansion: f of x equal to a naught by 2 plus summation a n cos n x plus summation b n sin n x. Then again write down the formula for a naught, a n, b n if you want. Or number 1, a naught equal to, write down the corresponding formula, then substitute for f of x and simplify the data, then determine what is a naught. Then a n, write down the formula, substitute for f of x, simplify, integrate, and then find the value of a n. Third, again write down the formula for b n, and simplify, integrate, substitute the limits, then determine what is b n. Then finally substitute these values a naught, a n and b n in equation 1. Equation 1 is the general Fourier series of f of x. Sometimes along with the Fourier series you will be asked to find the series expansion, or deduce some series expansions from the given Fourier series. So when you find the Fourier series expansion, by taking some particular value for x, it is possible to derive a standard infinite series expansions, some of the infinite series expansions. That can be achieved by taking a particular value for x. So usually first we'll prefer endpoints for the values of x. So after finding the series, substitute x equal to the endpoint, then keep this in mind, the point of convergence. Then if endpoint is not working, that means after substituting x equal to the endpoint, if you don't get the series that is given in the problem statement, then you have to take the middle point. Again, if it is not working, then you have to choose the middle point between any one endpoint and the actual middle point. So that is the way of choosing the particular value for x. Usually end points or middle point, then take the average of middle point and an end point, you get some other particular value, then substitute that value for x. ಸೊ ಜನರಲ್ ಆಗಿ ನಿಮಗೆ ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಕಂಡುಹಿಡಿಯಬೇಕು ಅಂತಂದರೆ ಪ್ರಾಬ್ಲಮ್ ಸ್ಟೇಟ್ಮೆಂಟಲ್ಲಿ ಫಂಕ್ಷನ್ ಕೊಟ್ಟಿರ್ತಾರೆ ಮತ್ತು ಇಂಟರ್ವಲ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಯೂಶ್ವಲಿ ಇಷ್ಟೇ ಕೊಡೋದು. ಫೈಂಡ್ ದಿ ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಆಫ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಸಮ್ ಫಂಕ್ಷನ್ ಓವರ್ ದ ಇಂಟರ್ವಲ್ ಇದು ಕೊಟ್ಟಿರ್ತಾರೆ. ಯೂಶ್ವಲಿ ಇಂಟರ್ವಲ್ ಕೊಡೋದು 0,2π ಅಥವಾ -π, ನೀವೇನು ಮಾಡಬೇಕಂತಂದರೆ ಫಸ್ಟ್ ಸ್ಟೆಪ್ಪು ಏನು ಪ್ರಾಬ್ಲಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಸ್ಟೇಟ್ಮೆಂಟನ್ನು ನೋಡಿ ಡೇಟಾ ಬರ್ಕೊಳ್ಳೋಕ್ಕಿದೆ. ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು ಏನು, ಇಂಟರ್ವಲ್ ಏನು. ಸೊ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈಸ್ ಎ ಪೀರಿಯಡಿಕ್ ಫಂಕ್ಷನ್ ವಿತ್ ಪೀರಿಯಡ್ 2π, ದಟ್ ಲೈನ್ ಫಿಕ್ಸ್ಡ್, ಆ ಲೈನನ್ನು ಬರೀಬೇಕು. ಆಮೇಲೆ ಇದು ಫಸ್ಟ್ ಲೈನ್. ಎರಡನೇ ಲೈನಲ್ಲಿ ದಿ ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಆಫ್ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈಸ್ ಗಿವನ್ ಬೈ ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು a0/2 ಪ್ಲಸ್ ಸಮೇಷನ್ an cos n x ಪ್ಲಸ್ ಸಮೇಷನ್ bn sin n x. ಅದನ್ನು ಈಕ್ವೇಷನ್ 1 ಅಂತ ಕರೆದಿಟ್ಕೊಳ್ಳಿ. ನೆಕ್ಸ್ಟ್ ಟು ಫೈಂಡ್ a0 ಈಕ್ವಲ್ ಟು ಅಂತ ಅಂದಮೇಲೆ a0ಗೆ ಫಾರ್ಮುಲಾ ಬರೀರಿ. ಸೊ ಲುಕಿಂಗ್ ಇಂಟು ದಿಸ್ ಇಂಟರ್ವಲ್ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ಆನ್ ದಿ ಫಾರ್ಮುಲಾ. a0 ಈಕ್ವಲ್ ಟು 1/π ಇಂಟಗ್ರಲ್, ಈ ಇಂಟರ್ವಲ್ ಕೊಟ್ಟಿದ್ರೆ ನಿಮಗೆ ಈ 0,2π ಕೊಟ್ಟಿದ್ರೆ 1/π ಇಂಟಗ್ರಲ್ 0 to 2π ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಡಿ ಎಕ್ಸ್. ಅಥವಾ ಈ ಇಂಟರ್ವಲ್ ಏನಾದರೂ ಕೊಟ್ಟಿದ್ರೆ a0 ಈಕ್ವಲ್ ಟು 1/π ಇಂಟಗ್ರಲ್ -π to +π ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಡಿ ಎಕ್ಸ್. ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿ ಅದನ್ನು a0 ನಿಮಗೆ ಸಮ್ ವ್ಯಾಲ್ಯೂ ಸಿಗುತ್ತೆ. ಸೊ ಅದನ್ನು ಒಂದು ಕಡೆ ಬರೆದಿಟ್ಕೊಳ್ಳಿ. ಅದೇ ರೀತಿ ನೆಕ್ಸ್ಟ್ ಎನ್ಗೆ ಫಾರ್ಮುಲಾ ಬರ್ಕೊಳ್ಳಿ, ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿ, ಬರ್ನೌಲಿಸ್ ರೂಲ್ ಅವಶ್ಯಕತೆ ಇದ್ದರೆ ಅಪ್ಲೈ ಮಾಡಿ ಎನ್ನದು ವ್ಯಾಲ್ಯೂ ಬರೆದಿಟ್ಕೊಳ್ಳಿ. ಅದೇ ರೀತಿ bn. ಸೊ ಫೈನಲಾಗಿ ಮೂರರದ್ದು ವ್ಯಾಲ್ಯೂ ಕಂಡುಹಿಡಿದಾದ್ಮೇಲೆ ಅದನ್ನು ಈಕ್ವೇಷನ್ 1ನಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, ಅಲ್ಲಿಗೆ ನಿಮಗೆ ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಸಿಗುತ್ತೆ. ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಆದಮೇಲೆ ಕೆಲವು ಸಲ ನಿಮಗೆ ಒಂದು ಸೀರೀಸನ್ನು ಅದರಿಂದ ಡೆಡ್ಯೂಸ್ ಮಾಡಿ ಅಂತ ಕೊಡ್ತಾರೆ, ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಸೀರೀಸ್ ಕೊಟ್ಟಿರ್ತಾರೆ. ಸೊ ಆ ಸೀರೀಸ್ ಡೆಡ್ಯೂಸ್ ಮಾಡಬೇಕಂತಂದರೆ ನಿಮ್ಗೆ ಏನು ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಬಂದಿರುತ್ತೆ ಅದರಲ್ಲಿ ಎಕ್ಸ್ಗೆ ಸಮ್ ಪರ್ಟಿಕ್ಯುಲರ್ ವ್ಯಾಲ್ಯೂನ ಚೂಸ್ ಮಾಡಬೇಕು. ಯೂಶ್ವಲಿ ಏನು ಮಾಡ್ತೀವಿ, ಎಂಡ್ ಪಾಯಿಂಟ್ಸ್ ಚೂಸ್ ಮಾಡ್ತೀವಿ. ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 0 ಅಥವಾ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 2π, ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು -π ಅಥವಾ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು π. ಎಂಡ್ ಪಾಯಿಂಟ್ಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಚೆಕ್ ಮಾಡ್ತೀವಿ. ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ ಸ್ಟೇಟ್ಮೆಂಟಲ್ಲಿ ಕೊಟ್ಟಿರೋ ಸೀರೀಸ್ ಬಂದರೆ ಡನ್. ಎಂಡ್ ಪಾಯಿಂಟ್ಗೆ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಇದನ್ನು ನೆನ್ಪಿಟ್ಕೋಬೇಕು ನಾವು. ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 0 ಅಂದ ತಕ್ಷಣ ಬರೀ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡಲ್ಲಿ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 0 ಬರೀಬಾರ್ದು. ದಟ್ ವಿಲ್ ಬಿ ಆ್ಯಕ್ಚುಲಿ ಎಫ್ ಆಫ್ 0 ಪ್ಲಸ್ ಎಫ್ ಆಫ್ 2π/2. ಎಂಡ್ ಪಾಯಿಂಟ್ ತೊಗೊಂಡಾಗ ಸೀರೀಸ್ ಬಂದರೆ ಯುವರ್ ಡನ್. ಬರಲಿಲ್ಲ ಅಂತಂದರೆ ಮಿಡಲ್ ಪಾಯಿಂಟ್ ತೊಗೋಬೇಕು. ಸಪೋಸ್ ಈ ಕೇಸಲ್ಲಾದರೆ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು π ತೊಗೋಬೇಕು. ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು πಗೂ ಬರಲಿಲ್ವಾ, ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು π/2 ಅಥವಾ 3π/2 ಅಷ್ಟಲ್ಲಿ ಆಲ್ಮೋಸ್ಟ್ ಬಂದುಬಿಡುತ್ತೆ ನಿಮಗೆ. ಇಲ್ಲೂ ಅಷ್ಟೇ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 0 ತೊಗೋಬೇಕು. -π +π ಬರಲಿಲ್ಲ ಅಂತಂದರೆ ಮಿಡಲ್ ಪಾಯಿಂಟ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು 0, ಅದಕ್ಕೂ ಬರಲಿಲ್ವಾ ಎಕ್ಸ್ ಈಕ್ವಲ್ ಟು +π/2 ಅಥವಾ -π/2 ಅಷ್ಟರಲ್ಲಿ ನಿಮಗೆ ಬಂದುಬಿಡುತ್ತೆ. ಸೊ ಅದಕ್ಕಿಂತ ಮುಂದೆ ಹೋಗೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. ಸೊ ಹಿಯರ್ ಯು ಹ್ಯಾವ್ ಎ ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮ್ ಆನ್ ಫೋರಿಯರ್ ಸೀರೀಸ್ ಎಕ್ಸ್ಪ್ಯಾನ್ಷನ್ ಆ್ಯಂಡ್ ಹಿಯರ್ ದರ್ ಇಸ್ ನೋ ಡಿಡಕ್ಷನ್. ಡೆಡ್ಯೂಸ್ ಮಾಡಿ ಅಂತ ಯಾವುದೂ ಇಲ್ಲ, ಸಿಂಪಲ್ ಪ್ರಾಬ್ಲಮಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಬರದೇ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ಕೊಡ್ತೀನಿ. ಇದೊಂದು ಮಾತ್ರ ಹಾಗೆ ವಿಡಿಯೋ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. obtain the Fourier series expansion of f of x equal to 1/2 π minus x in -x -π less than x less than π. So this is the problem statement. This is problem statement. Now we need to find the Fourier series expansion of this using the corresponding formulas. So solution. Here I have not followed the exact method that I mentioned here. So first what you have to write here, given f of x equal to π minus x/2 and the interval -π comma +π. Then write down the general series expansion. F of x equal to a0/2 plus summation an cos n x plus summation bn sin n x. Then a0 equal to 1/π -π to +π f of x dx. Substituting for f of x, you get 1/π -π to +π π minus x dx. So integrating this you get π. Then an equal to 1/π integral -π to +π f of x cos n x dx. Then substituting for f of x, you get pi into cos nx first term minus of 1 by pi, the same thing, 1 by pi we have taken outside, x into cos nx dx. So pi cos nx, that is an even function, x cos nx dx. X is an odd function, cos nx is an even function. So product of an odd function and an even function is odd. So the value of this integral will be 0. How this will be 0? As per this formula. As per this formula, since the integrand is odd, the value of this one will be 0. So 2 to get cancelled, you remain with integral 0 to pi cos nx dx. Here cos nx is an even function, pi is constant, so this will be an even function. Or you can directly integrate in this, you get 0. Then write down the formula for bn, then substitute for f of x and simplify this, you get bn equal to minus 1 power n divided by n. So here I got a naught equal to pi, an 0, bn minus 1 power n by n. Substituting these values in the general Fourier series expansion, we get f of x equal to pi by 2 plus summation n range from 1 to infinity minus 1 power n divided by n sin nx. So this is the required Fourier series expansion of pi minus x. So practice this one, write it on your own and try to solve on your own. Once look at this, ಒಂದ್ಸಲ ಇದನ್ನು ನೋಡ್ಕೊಳ್ಳಿ, ಆಮೇಲೆ ಒಂದ್ಸಲ ನೀವೇ ಹಾಗೆ ಬರೆದು ಟ್ರೈ ಮಾಡಿ. ಎಲ್ಲರೂ ಕನ್ಫ್ಯೂಸ್ ಆಗೋದು ಅಥವಾ ಏನಾದರೂ ಮಿಸ್ಟೇಕ್ ಆದರೆ ಆಮೇಲೆ ಮತ್ತೆ ಇದನ್ನು ನೋಡಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಬೇರೆ ಪ್ರಾಬ್ಲಮ್ಸಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ತೀನಿ. ಥ್ಯಾಂಕ್ ಯು ಆಲ್.